How
There
about
we go.
now?
Yep, that works for us if it works for you.
Yes, it does.
Excellent. So I'm going to hand it off to Ryan and Thomas now, who are going to talk about Hidden Cobra. So one of the things that I always like to discuss, nice state-centered threat intelligence analysis. So with that, I will turn it over to you guys.
Thanks, Joe. My name is Ryan Sherstobitoff, and I have my colleague here, Thomas Roccia. We're part of the McAfee Advanced Threat Research team. We work on a number of different things, including nation-state activity. So today's presentation, which we've actually given at another location previously due to canceled travel, is a deep inside look at Hidden Cobra and the cyber offensive programs that are involved with this threat actor. So some of the things that we're going to talk about here today is the goal and objectives of a nation state in the geopolitical context. We'll also talk about the background on different cyber offensive programs. We'll also discuss about what is Hidden Cobra, and also what is the known techniques, tactics, and procedures, followed by a review of the tooling, as well as some interesting insight from Thomas about code overlap and data science models that we've done previously. We introduced ourselves a little bit here, and so let's move on here. So first thing here is, what is the goal of a nation state, and what is the geopolitical context that drives these different nation state actors? So from a nation state threat perspective, there's several things from a cyber domain perspective that is driving a nation state. Some of these are political, some of these are foreign policies. So some adversaries are interested in driving intelligence requirements to gather information on individuals that might be, or organizations that might be influential to changing foreign policy or informing foreign policy, military, financial, and influence campaigns. So these are the top 5 things that an adversary might be interested in terms of a nation state perspective. So how does the geopolitical situation influence cyber offensive programs as they relate to Hidden Cobra? Several things come to mind. One would be the adversary here that we're talking about, Hidden Cobra, is often reacting to sanctions. So a lot of the times there is reactions based on changes in a country. There's reactions based on different changes in geopolitical situations that are occurring. Targeting opposition and state enemies. So groups that oppose Hidden Cobra or North Korea, or state enemies that would be considered a threat to the ideological kind of perspective of North Korea, would be a target that would be in relation to some of the objectives that they drive, seeking foreign military technologies, which is a number of kind of things that we've seen in the past related to Hidden Cobra, is looking for military technologies, targeting humanitarian aid groups that report on the human rights issues in North Korea, as well as different other opposition groups that are, such as defectors, etc., that might be of interest to run a state-driven intelligence operation. So some of the general background on a nation state in some of the cyber offensive programs here. And what is interesting here is that most nations have some form of cyber offensive program. So whether it be smaller countries or whether it be more modern developed countries, there is some form nowadays of a element in the cyber domain, which would refer to offensive CNO operations, or computer network operations, and computer network exploitation, which is a blanket statement for offensive programs. And also we have programs that are designed to accomplish state goals. So some of the things that are driving the policies and decisions coming from the top leadership will often be reflected in a cyber operation. And last but not least, as we know from an industry and community perspective, attribution of these cyber attacks are challenging, often fraught with analytical problems and misdirection and misattribution. So it becomes challenging for private sector and government to do full attribution. And that's what makes cyber offensive programs more effective than a military kinetic response. So talking about what is Hidden Cobra, or who or what is it, is an interesting frame of mind. Hidden Cobra is the umbrella classification for the US government's North Korean cyber offensive program. So this would actually encompass all the subgroups, all of the different kinds of activities that we know as Lazarus, Andariel, Bluernoff, and essentially encompasses it into a larger set of classifications. So we'll see that the activity set will map across multiple groups that the private sector has different names for. So here we have a number of different names that have been coined referring to Hidden Cobra as an actor. But from an analytical and intelligence perspective, there's several things here that we can tell from just group naming conventions. Yes, the private sector has identified that Hidden Cobra is referred to by multiple names. However, the target objectives of these different groups differ when compared to each other. Even though that they're residing under the same umbrella as each other, different ones like Lazarus versus APT-38 versus APT-37 or Kimsuki have different objectives. So we'll see that Lazarus is targeting a lot of cryptocurrency. We'll see that some of the less known groups here under Hidden Cobra would be doing militaristic kind of traditional covert espionage against targets that would be state enemies. And so we see this distinction from a activity and targeting perspective, but from a overall classification, it's rolled up into Hidden Cobra, but can be subdivided based on different kinds of activities. So a brief statistical overview of activity that we've seen from McAfee back in 2019 Q4. We have separated two types of data here to show just a short statistical overview. On the right-hand side, we have a pie chart that is referring to file types for this adversary that were most prominently used in Q4 of 2019. We see that there's PE files, DLLs, documents, ELF files, Linux ELF, including Mac-O, which is Macintosh binaries, as well as on the left-hand side is a mapping of command and control servers as they geolocate throughout the different parts of the world. And then mapping all of these against the MITRE ATT&CK framework. I'm sure I don't have to give too much of an introduction on what that is. Essentially just mapping different techniques from a technical perspective across the kill chain. And we'll see that these are the group buckets here of all the activity in Q4 2019 that is in reference to MITRE ATT&CK. So breaking it down further now into Hidden Cobra, what is the threat profile? What is it? So Hidden Cobra here is using cyber operations as a means to accomplish military goals. It originally started back in 2007 in different variations of cyber offensive programs. It really was a means to supplement kinetic activity with more of a direct approach towards enemy nations. So because the country behind Hidden Cobra wasn't able to afford doing a true kinetic response, due to aging machines, aging technologies, it makes more sense to have a cyber offensive program, which is basically one more cost effective than conducting a full out conventional war, especially for nations that are heavily sanctioned by different economic conditions. It also helps to create a level of deniability for whom is actually responsible for it. So they're often creating, back in the early days, blaming it on different groups, false groups, hacktivism. You know, that's not so much the case now. It's more of like they don't really care at this point. But originally, a lot of this stuff, especially during the era of Operation Choi, back in the paper that we released in 2013, the encompassing activities actually mapped across a number of different fake groups. Nowadays, they don't care. One other aspect too is disrupting or deceiving enemies anywhere in the world at any time. So it actually reduces the cost to do cyber war in the cyber domain as opposed to kinetic response. It's really why Hidden Cobra has become quite sophisticated at doing cyber offensive programs, given its inception early on. Even before cyber, they were doing radar jamming and other electronic kind of intercepts that were pre-internet, sophisticated computer technology. So moving on here, we kind of put together a number of prominent activities or campaigns that we've seen in the last 2 years that have been attributed in one way or another to Hidden Cobra or one of the subgroups. And some of these are McAfee ATR publications, and some of these are based on public reporting. So there's a number of different incidents that have occurred on a frequent basis over the course of 2 years with different naming involved with it and different TTPs. You can see that there's a lot of financial and cryptocurrency related campaigns that are supporting the regime, especially during times of economic sanctions. There's also situations where, especially in fake job recruitment campaigns that we saw in 2017, 2018, were focused on gaining access to military technologies that were being deployed in and around the region that would affect them. So with that said, the brief timeline of events, we move into some of the general modus operandi of known attacks that are associated with Hidden Cobra. So some of the top 3 things that they're doing here is circumventing sanctions. So as I'm sure the industry, this community is aware, there's a number of things that are actually being done to evade sanctions here. So basically, they're through the means of cryptocurrency, bank heists. We're also seeing that North Korean defectors are in opposition groups here are being targeted. We're also seeing that, past in previous campaigns, we're seeing access to foreign technologies and defense industrial base being targeted. And so we're actually seeing a wide range of different things that have occurred over a period of several years in terms of changing of modus operandi. So now we're going to do a little bit of a deep dive into some of the campaigns and some of the things that we have seen. Most notably, we started here with Operation Sharpshooter, which was actually a campaign that was set to kind of look at different critical industries. So it was a global campaign that appeared in 2018. And this campaign here was targeting different targets in the Middle East, along with new activity that appeared in 2019. Also, a new implant known as the Rising Sun was used against targets. ATI discovered additional links to other Hidden Cobra attributed activities. So essentially, based on all of this data and all this information, which also included having access and insight into a command and control server, gave us some additional means of tracking stuff going back to 2017. So some of the the key points here. Actor was essentially compromising servers to host command and control code. We also observed different Chinese web shells used to maintain persistence. In addition, the actor was connecting via ExpressVPN to manage the hacked assets that were involved. Real quick, you can see here on the left here a screenshot of the web shell that was used to maintain persistence. We also see that the log file over here is showing that the actor had connected to this page here, which was the web shell. Moving on, these malicious certificates we also discovered were identified to be tied to the C2 infrastructure. So based on sharing of TLS certificates, we're able to actually determine that there was a number of different servers that were used over the course of several years. Most notably, it was with different infrastructure in different countries, but by tracking and using these shared TLS, we're able to identify sharing of infrastructure amongst multiple campaigns, as going into this slide here, talking about the different connections to other operations. And so this is kind of broken up into different clusters here. So on the top right-hand side here is a campaign back in 2017 that was targeting defense contractors. And they had a number of different malicious documents. On the little bit to the left, the 2017 Lazarus cryptocurrency attacks were sharing some of the macro techniques and also sharing other characteristics with other parts of the campaigns, including Rising Sun version 2. And then Rising Sun version 2 is sharing infrastructure with a number of different IP addresses that also shared infrastructure with different Lazarus cryptocurrency attacks and so on. And essentially, the common core here was the malicious SSL certificate, which was essentially shared amongst multiple different stages of implants, different activity over the course of several years. Now, in this chart here, or in this slide here, we're going to talk a little bit about the backend code that we had identified. And so what was interesting is that we worked with international law enforcement to obtain information about a command and control server. From our investigation, we were able to see that the backend was written for Operation Sharpshooter in Python code. And then later iterations we had discovered to have been written in ASP language. So backend used essentially a multi-layered approach here in terms of relaying commands to the master server. So in the diagram here is we have an intermediate C2 server. So some victim infected with Rising Sun would send commands which would then be relayed through the command interpreter to the intermediate C2, which was the hacked server, and essentially relayed upon upstream to the primary C2, which at that time was the following IP address. So, and the component main menu.php was a command interpreter designed to interpret the different codes and commands coming from the infected endpoint. Framework PHP was designed for downloading the implant. It was actually, the link was embedded directly into a malicious maldoc, and therefore was able to load a Rising Sun implant directly into memory on the victim system. So by having access, what we learned from this here is that we had access to give us a kind of like a signature to hunt for additional infrastructure that had similar kind of communication patterns as what we had seen here in Sharpshooter, which led to the discovery of ASP servers and things like that. So breaking down the command format here, in the command handler, the data acceptor, which was the main menu.php, there's actually several different parameters that were accepted here. For some of the most interesting ones was the result, which was sending results of command execution back to the command server. And this would actually then be sent back to the primary C2 that then would relay back to the endpoint, do some further instruction. The set command was obtaining a new IP address of the actual master server. So that point, it can then relay to a different master server. So they basically are changing out the servers behind the intermediate server. So not going into super detail here, but essentially, this is the common format that we're able to see in PCAP files that were associated to infections on Rising Sun or other malware that utilized similar infrastructure. And we actually dated that back to 2017, being able to see this various kind of activity here. Some additional Python analysis. So some of the other hard-coded activity we saw here was being able to check it against IP addresses, being able to make sure that log files have a rotation and deletion. We also seen that there is ways of blacklisting and whitelisting different IPs that they don't want to have the Rising Sun implant delivered to, possibly testing networks that these adversaries were operating from. And so further, just a little bit more details about how the infection actually works. So one of the ones here where we're seeing a malicious document delivering a payload, there was a first stage implant which would load into memory, which was basically responsible for collecting initial information. And so that was actually retrieved by framework.php and hosted on a hack server. And so some of the capabilities of that in-memory implant was gathering user agent, collecting file path, processes, etc. Really was the idea here to understand what that machine had on it, then deliver an actual encrypted payload into memory, then decrypt Rising Sun version 2, which was actually incorporating SSL and strong encryption in the traffic. Different than the previous ones that were sending information in plain text. So in Operation Sharpshooter here, this is just a basic slide here on the comparison between different PCAPs that we have analyzed of traffic associated with Operation Sharpshooter. As we can see here, the original Rising Sun implant appearing in 2018 is sharing a very similar HTTP request as Operation Sharpshooter. We also saw that there was variations that were interpreting for ASP-based command handler. We also saw that they're sending or setting the accept language request setting in the header as co-KP referring to North Korean language set. So they actually had created the backend code into two different flavors, ASP and PHP, which were basically supported with some Python code. And so some additional functionality here, vendor PHP was a file here to collect logs, checking of user agent data, and essentially serving up, as we saw in the previous diagram, Apple PNG to the downloader itself. So when we look at this from an overall capabilities perspective on different versions of Rising Sun that we've seen over the time, we've broken up here the three different kinds of methods here. So C2 and configuration data and how it's changed between V1 and to V1.1 to V2, the communications mechanisms, deployment techniques, essentially based on access to the server, based on access to the other stuff, we're able to see that Rising Sun can be traced back to 2015. And we can trace this lineology here as far as samples originating in the public domain as early as 2017 that are most related to what we were seeing in Sharpshooter. And last but not least, on Operation Sharpshooter section here, some additional activity appeared in 2019 post the release of the command and control server in a public report. There was additional targeting to Middle Eastern victims using the ACE WinRAR vulnerability. Specifically, again, they are spoofing legitimate sysaid product documentation that actually contain the Rising Sun downloader. Infection mechanism was pretty much the same as before. So moving on, we're going to start digging a little bit further here, changing topics, going into more about the tools and the implants here. So as we've tracked over the years, there's been a number of implants in functionality developed in a code factory-like method. We have several samples or different versions by name, which is US Cert classified implants. These are the ones that you see in those Department of Homeland Security releases with these fancy and funny names. We also see that there's a number of industry classified implants that we've seen over the years. Golden Dragon, Rising Sun, Destover, Noops Bed, etc. What we see here, though, is that implant development, the past, the present, and the future, they've had timelines of development here. Each of these implants have originated from a certain point in time and over the years have been updated and revised. We've taken several different implant families based on detection names, and we've mapped out the timeline of development based on when they were created. Backdoor, Actor, Scarcraft, HWDoor, and Ascot, and these are the samples that we've seen in the wild observed by McAfee Labs and their development timelines. As you can see that many of these have originated 2014, 2015, 2016, and essentially have reappeared in 2020. Same goes for Destover, Noops Bed, and Noops Bed is actually related to a number of the more recent Hidden Cobra operations. Destover, as you're probably familiar, is tied with a number of different wiper incidents over the years. It also has an equal development timeline appearing from 2016 all the way to more modern times, as well as Noops Bed and Trojan Noops Bed, 2014 and so on. And so just a little bit of information further into Trojan development. So HWDoor is a broad detection name for, but reliable for, Hidden Cobra backdoors. HWDoor has been in operation since 2013, Operation Troy, and thus we've seen additional variations of this backdoor appear in 2020. And so as we see here, that this screenshot here for the HWDoor, this is just taken from the most recent variation of it. Again, setting the common stuff, HTTP language headers, server log files, and so on. So this is just a general, snapshot into that. Ascot, again, is another Hidden Cobra implant that's been around for a number of years, most notably in Sony Pictures and previous than that. It has a development timeline going back from 2014 and beyond. Last active development of Ascot was in April 2019. So moving on, my colleague Thomas here is going to talk about a little bit about using graph correlation to identify malware DNA. Thomas?
Thanks, Ryan. So let's talk about graph correlation. So Ryan was talking about analyzing samples and trying to find a relationship between them, understand the functionality and so on. But everyone knows that when you have to deal with thousands of samples, it can be very difficult, to understand the same functionality and the sharing code between the different samples. So to solve that, what we try to develop is to create a methodology around graph correlation, which aim to identify the malware DNA. The goal of the graph correlation is basically to understand the trends between different samples or different campaigns. It will also help to get you some evidences about shared functionalities, and it will also help you to directly spot similarities between different campaigns. So this is very helpful because it can be very scalable. It helps to identify directly the same functionality or the similarity between the samples, but also the campaigns and the operating method used by the attackers. And finally, all that evidence compiled in graph correlation will help you to draw some hypotheses. Next slide, please. Yes. So before to dive into the graph correlation concept, let's talk briefly about the graph theory. So basically, graph theory is about putting in a structure a set of objects and put that object in a relationships. So we call each of the object a node, or you can also call that nodes vertices. And we joined the nodes between them using what we call an edge. This is basically the link between the different nodes in your data set. So basically the goal of that is to directly spot the similarity between two sets of objects. So we also use the Jacquard Similarity Index, which is basically an index used to compare members for two sets. So basically, we will deep dive more in details about this concept. But basically, we will use the Jacquard Index, which will help us to calculate the distance between two different sets. So the first things we use with graph correlation is the string similarities. So to understand the Hidden Cobra campaigns, we extract the strings of many samples we collected from the different campaigns, and we calculate the distance between the strings, meaning we are just identifying the amount of similarities of the strings extracted between different samples. And we use the Jacquard distance to calculate that distance between the strings we extracted. So that's an example on Hidden Cobra samples. So what we did here, we extracted all the strings and we compare directly the similarity between all that samples using the strings. And we put in a graph, which we call the graph correlation, the different samples. Every link will indicate you the relationships between the samples. And the more the link is strong, the more the similarity is. And here it's really interesting because we can clusterize all our findings. So that's an example. When you extract directly the strings, you will be able to identify cut similarities because we know that strings can be shared between different samples and it can be reused on different codes. So here for us, it's really interesting because we have been able to identify similarities between different samples. So here, that's an example where you can see electric fish, which is known samples from Hidden Cobra, and type friend, which is another one. And here we can see some evidences that there is between the both samples. There is also some other samples on that slide where you can see some similarity with the samples Hoplite and Ghostek. And this is really interesting because directly we can spot evidences of sharing functionality and sharing code as well. We use as well the match hash. I will talk a bit more about that in the next slides. But basically, the match hash is based on the code, and it's an addition to your code correlation and your identifying similarity between the samples.
So moving on a little bit here, we also did a clustering by PE-rich header. So we took and found that PE-rich header to some degree is useful for tracking samples, but obviously be aware of false flags. We took 324 samples from 2018, 2019, and extracted the rich header information from it, then essentially correlated these amongst each other to determine different intersects of where malware shared different development theories or development environments. So as we can see here, the purple dots are the family, the dark orange dots are the hash, and then the yellow or orangish dot is the rich header. So there's actually several different clusters that intersect with each other. And so then when we start breaking out the clusters, we reveal interesting links. So we have here like Noops Bed, Destover, Hoplite, Go Secret, Crowded Flounder all share similar environment, as well as Ascot, Destover, Bad Call, Bang Shot, Manuscript, HWDoor, and Fake Jobs in Typeframe all make up a cluster. So essentially this is interesting, as we can see that the same developers were responsible for multiple different clusters of implants that have been used and linked to Hidden Cobra. So now Thomas is going to go back and talk a little bit more about the map choke and the code similarities. Thomas?
So the PE rich header is very interesting because it can directly give you some information about the compile environment, and also to go a bit further, we also use, as I said, the matchlock hash. So basically, the matchlock hash is a concept from the French cybersecurity agency, where they're currently creating a hash based on the control flow graph. So basically, the code will extract the CFG of the samples and calculate a hash related to that control flow. So this is very interesting because we can extract that different hash for a whole sample, or for some part of code for specific samples, just to identify, for example, some functionalities. So we use that technique, and we clusterize them to identify similarity between the samples. This is more scalable and more easy to use, and it helps you directly to spot evidences and code sharing between the samples. So that's an example here with bank shot and bad call. So here we extract the information about the SSL proxy code, where we can see that the code is similar between both of the samples. And we discover that there are more than 65% of similar functions between the both samples. And here that gives us the information that potentially the samples was created by the same teams, or there is some code sharing between multiple teams. So here it's a real example where you can identify directly code sharing between two different samples used in different campaigns. Another examples with two other DLL where we can see the same functionality used directly with the CFG. So here we can see the same CFG for the similar CFG for different samples. And finally, that leads us to the conclusion. So when you analyze all that that code, all that information, the goal is really to understand where those come from, that code, where what the actor are trying to do, and what kind of code they will reuse for the future. So this is really interesting for us because it helps us to understand what's happened in the past, but it helps us also to spot new malware family in the future and identify new attacks. So we came to the conclusion that we think that there is a code factory behind the code and the samples used by Hidden Cobra, mostly because we identified shared functionalities between different campaigns, but also relationships with the infrastructures or specific keywords, or also SSL certificate and so on. So this is really interesting for us as a defender to understand how a nation state can operate using same functionality and sharing that code for multiple campaigns.
So in conclusion here of our presentation on Hidden Cobra, some of the key things to take away from this is that Hidden Cobra is a well-organized and aggressive attacker. Essentially, they are conducting cyber espionage, sabotage, and cybercrime campaigns. They're also keeping their tools, their arsenal up for more than a decade. And then by following their campaigns with graph correlation, it allows us to proactively detect this and draw a story around it. And last but not least, analyzing and studying to reveal the multiple teams inside the group that are working with the same DNA but have different goals. So thank you very much. I'll pass it now back to Joe.
Thank you, guys.
Hey, thank you very much, gentlemen. Ryan, Thomas, excellent job. It's always fun to see and hear about the dissection of a threat actor or a threat group. So that's a lot of detail and reminds me I need to reread. I know McAfee published, probably you guys were the primary authors on that, some